Last night was a battle royale, homebrew battle royale. What be this sorcery? We get some signal from the antenna and we feed it in this end, and we feed a local oscillator frequency in this end, and from here we have the sweet sound of continuous wave Morse code. Well, presently the direct conversion receiver is not behaving itself. One thing I found out, and this might save you a lot of expense and a lot of wasted time, this DC regulated power supply, which is recommended for powering transceivers and whatnot from Jaycar, generates a crap load of hum, which, you know, people have warned me about and I didn't listen. So what you need to do if you're building QRP gear is save yourself the hassle and get yourself a nice lithium ion ore. This is just a sealed lead acid cell, 12 volts, very, very simple. I'm going to charge it with this charger here, and I've made it so that, modified it so that you can disconnect the charger so we don't have any hum coming into the system. And you know, I've crimped on some leads so that we can plug into the battery. And then at this end, all I've done is I've taken some electrical connectors I already had, so I'll be able to screw down whatever I'm operating on the bench. And I have 12 volts of DC, hum-free, so that's one thing that I can take out of the equation as causing hums. So if I've got an audio circuit that's generating hum, I know it's not the supply that's causing it. Yes, scatological as ever. I've bought myself some diodes, so the plan now is to modify the receiver, and we are going to do a Frankenstein's monster approach to this, which once again is probably not the best approach because you don't know whether the parts will marry with each other. But hey, what's happening is I'm learning so much in this process, regardless of whether it succeeds or fails. I'm just off to RJ Turk now, which is an electrical supplier in Australia, because I know that if I do not put a inline fuse in this system, I'll short the battery out and it'll explode in my face. Okay, it's always wonderful to get a little bit of exercise in. Can't sit at your test bench all day building stuff and eating Cheetos. It's not a very healthy thing to do. It's probably like a couple of Ks there and back, which is 4 Ks for the morning, which is a good walk for me. And we'll see if we can get the inline fuse holder we need. What I am quickly realizing is that there's a lot of considerations when you start home brewing, and the initial expense is quite high, but I'm hoping that over time the expenses will come down as I get the gear I need. And I've got a lot of stuff now that I can work on, DDS VFOs and whatnot, so I think I'm almost there. At least I'm hoping so, because the Visa card is starting to groan. The $6 Kmart Crocs in need of a bit more breaking in, I think. Rock and roll. So, a couple of quick thoughts on homebrew. And I'm talking about home brewing, of course. I'm not talking about beer home brewing, although we might do a story on that another time. Had some great times at Maritime College home brewing. Anyway, like I was saying, the tooling up for the process is quite involved, and perhaps by watching these videos you'll avoid some of the mistakes that I've made. So like I was saying earlier in the video, I bought myself a regulated supply assuming that it would be made well, and maybe it has a very minimalist ripple on it, but it still causes me issues. So any problem you have is obviously the opportunity for a project. So I could think about some filtering on the output of that supply. So comment below if you've got some ideas on that front. But it's taking me away from my main purpose, which is to receive a signal, any signal. It can be from next door, I don't really care. But I'd like to be able to receive a ham signal on the 3.5 megahertz band. So that is my priority, and that is what we are working towards. And I'm hoping that in a video to come, I'll be able to show you that. Please remember to like and subscribe. Just press the subscribe button, it's not hard. Nearly there. Made it. As I strongly suspected, RJ Turk doesn't have any 12 volt stuff, so as luck would have it, we have a Repco nearby, so hopefully they have what I need. We'll see.
You still haven't pressed subscribe. Why not?
Success, but I think we'll have to go back to RJ Turk to get a lower value fuse. We had to go back to RJ Turk to get the fuses, and the lowest value they had was 5 amps, which I would have preferred 2 or 3, but hey, it's better than nothing. So, like I was saying, this is the supply that I kind of bought on the spur of the moment. It's 12 amps maximum. I was always planning on operating QRP, so I didn't want to give myself the option of running a 100 watt rig. But when you look at how this is designed, one of the things that's really annoying about it, I'll just switch it on, is, I don't know if you can hear it, but it's got a very loud fan. So if I was going to be operating this, all the time, I'd probably want to have it below the desk or further away from my operating position. It's just really annoying. And the other thing is, once again, I don't know if you can hear this, but I'll just put the microphone near the speaker. There's quite a bit of hum. Now, I initially thought that might just be the actual LM386 chip playing up. But I'll just show you. So just take this as option 1, and I'm just going to show you what the same circuit powered up on a pure battery source sounds like. We'll just pop our little fuse in. I think it's 5 amps. I probably would have preferred something a little bit lower than that, but that is all they had. So we're now fused up, so no boom pow kabam in my face. And this is the same circuit powered up on batteries, and that hum is completely gone. And I don't think the amp is working as it should, but we're certainly not picking up all that hum. So, you think you've got what it takes to be a home brewer. Well, let me tell you something. I thought I had what it takes to be a home brewer. I thought that I had the necessary knowledge. Well, there's a few things that you need to look out for, and I'm hoping that these pointers that I'm about to give you will be helpful. They may give you the opportunity to avoid a huge amount of time and frustration. But the first thing that I need you to understand is that, and I come at this from the point of view of someone who's worked in the field of education, is that the things that cause you the most trouble are quite often the things that teach you the most as well. It's like being married. If you were to look at earlier in this video the shambolic mess that's been created in the process of trying to create a working receiver, all along the way, each of those mistakes has taught me a great deal. And provided you have what's known as a growth
mindset,
you can learn a lot from the discoveries that happen because of the silly mistakes. So I'm going to just describe a few of the things that have happened to me along the way, and they may be of assistance. Point number 1 is, quite often you'll just jump on Google and go, give me the pinout for a 2N2222A transistor. And it's fantastic that that information is at your fingertips. But I went to Jaycar to buy this particular transistor, and it comes with a data sheet. And I thought, well, I can't be bothered downloading the data sheet. I'll just Google what I need. Unfortunately, the 2N222A transistor comes in a variant that starts with a P. And for that one, the collector and the emitter are swapped around. So that was one of the first problems, that I was just building these circuits and they weren't working very well. I was occasionally hearing what I thought was Morse code very, very faintly. And of course, that's probably because if the transistors are wired in backwards, if they don't blow up on you, you're probably going to end up with very, very low gain. So the receiver may well have been working, but very, very poorly. So that's point number one. Use the data sheet that you've got with you. But what did that mistake teach me apart from using the data sheet? Well, it taught me how to tell if you have an NPN transistor, which is the collector and which is the emitter, by using the diode function on my multimeter. Now, I'm not going to go into that. You can Google how to do that. But that's something that I learned from that mistake. And then there was lots of other mistakes along the way. Also, it's kind of like doing a really beautiful painting. The more challenging the painting, the more interesting the palette becomes. With all the mistakes you've made with color mixing, and that's kind of what's happened in this project as well. So I started building a very, very simple, inverted commas, receiver that was designed by Peter Parker, and I stuffed it up, and I think I stuffed it up for a number of reasons, but at any rate, it wasn't working. And then I went to an Alan Yates design, which is the one that I'm kind of building at the moment, and that had its problems because the next thing I learnt, that toroids, you know the old commercial, oils ain't oils? Well, coils ain't all coils. And so I found some toroids at Jaycar, and I didn't know what type they were, or what permeability, what type of material, etc., etc. They're very, very heavy, and I think they're actually for suppression of RF, and they probably absorb RF. So when I put these in my double balance mixer, diode double balance mixer for the receiver, my direct conversion receiver, the DBM that I actually built was probably a signal attenuator rather than what it's supposed to do, which is mix the signals. So what did I learn from that? Well, I strongly suspected they were the wrong toroids. So I went to Minikits. I've got their mail here, that the toroids, this is the actual package they sent me. These guys are amazing. You put an order in, bang, it's there straight away. They even give you their phone number. Yeah, just an amazing company to deal with. And they had the toroids that I needed. So I went to them, and then I went online, and I will put links below to Charlie Morris's video and various other videos that I've used. So by building that DBM, I learned how to do a bifilar winding on a toroid. And I also learned that coils ain't coils. So that's one more thing that I've learned along the way with the failures that I've had. Oh, God. And finally, I'm going to learn how to actually put my microphone on so that it doesn't fall off. So that dropped it about 16 times. I've had complaints about the volume in my videos. It's probably because I've almost smashed my mic every time I've used it. Also, once I got started, I found some Pixie designs. And I started building the Pixie. It looks really, really simple. Schematics that you're given quite often are not complete. They'll sometimes have, like on the Pixie that I had, it said for the output it had a picture of a speaker, but there was a little greater than 8 ohm symbol. So they wanted a speaker that's greater than 8 ohms, which makes me think that it probably was supposed to be a fairly high impedance. So volume was crappy. It kind of worked a little bit at certain points in time, but then it stopped working. That was probably because the transistors, the 2N222A transistors that I was using, were wired in backwards. So that frustration, like I said, I learned how to find out about that variant of the transistor and how to tell whether I'm looking at the collector or the emitter on an NPN junction transistor. So all of these problems that come along, if you are consistently working towards finding a solution, you will find a solution. And sometimes, you know, you can decide, no, I'm going to call quits on this, or I'm going to try and do something else. But my mistakes have actually helped me get to the point where I have a receiver that's receiving something, because the LM386, that was the next thing I learned. LM386, they say amplifier on a chip. What can go wrong? Why would you bother with 3 or 4 transistors when you can just use one IC? Well, the schematics don't tell you a lot of the things you need to know about this IC. For instance, when you earth it, they talk about a star earth. If you've got earth lines running all over the place and earth loops and everything, the LM386 makes a great oscillator and a terrible audio amplifier. So you've got to go off and do some research on the LM386 chip and work out how to earth that effectively. That's another thing that I've learnt. So along the way, my mistakes are still feeding into my final aim, which is to get to a point where I'm actually receiving a signal. Now, this first receiver is going to be garbage. I know that. But if it picks up a signal and I can listen to something on it, it's, for me at any rate, because I'm a total nerd, a very exciting thing. The fact that you can stick a piece of wire in the air and hear people thousands of kilometers away. Even on this bare bones receiver, no front end, no selectivity, I've picked up a CW station in New Zealand. So it's exciting stuff. It just picks it out of the ether. And then you've got this little board with a handful of components on it, and you can feed in RF in 2 places, and out the other end comes audio. That is pure alchemy as far as I'm concerned. It's really, really, really exciting stuff. So yeah, once again, I can't help it. I'm a total nerd. The thing to remember with homebrewing is that it will have its painful moments. I've been up till 2 or 3 in the morning pulling what's left of my hair out, hence the wig, and just getting very, very frustrated at times. But every now and then, you might hear a little bit of a signal or a crackle from an amplifier that stopped oscillating, and you can feel yourself heading towards some solution. Now, ultimately, why I'm doing all of this too is to practice building stuff, because I have a really nice kit that's going to be a CW transmitter from QRP Labs, and it actually decodes Morse, and it's a very beautiful little kit. But I don't want to destroy it, and I've got to say, as kits go, it's not hideously expensive. It's like $200 and something, 270 Australian dollars or something like that. I shouldn't really be that worried about it, but I do want that kit to be a success and be put together well. So at the moment, what I'm doing is I'm going to build a bare bones receiver, I'm going to build a bare bones transmitter, and I've ordered a software-defined radio. Now, that's a bit of a cop-out because I wanted a totally homebrew station. But the software-defined radio is so that I've got a reasonably accurate frequency reference for where I am on the band. So when I do get my license, if I'm transmitting continuous wave, I'm in the right section of the band. I can also see if a transmitter's generating harmonics and whatnot in places it shouldn't. I can work out where I am on the band. I don't want to be transmitting somewhere where I shouldn't be. So that's basically where I'm at. Homebrewing, give it a go. As the guy on the Dilmah ad says, do try it. It's a fun thing to do. You will learn so much, and even if your station doesn't have all the bells and whistles and it's not fantastic, think about how exciting it'll be to throw some components on a board, build a 1-watt transmitter, and then speak to someone on the other side of the country or perhaps the other side of the world. That is a real challenge, and that's what's exciting about QRP and about homebrewing. Anyway, this video has probably gone way longer than it should. I'm hoping someone gets something from it. Please comment below, and if you would like me to talk more about some of the challenges that were met while I was doing this build, or you have any questions. I am not an expert. I do have a qualification in radio communications. It's not a degree qualification, it's an associate diploma. I was a ship's radio officer. I was trained how to service transmitters and receivers and whatnot, but it was a long time ago, and a lot of beer has flowed under that bridge since that time. So it's knowledge that I'm having to definitely refresh on. So we're all hopefully learning together. We're all hopefully getting excited by the possibilities of home brewing. So I would love to see some comments below, and I could perhaps talk about, you know, some of the things that, some of the sites that I've gotten designs from. But like I said, a huge shout out to Charlie Morris, to VK3-Way Peter Parker for his fantastic designs and inspiration, and to Alan Yates and his lab blog, and a large part of this receiver that's now kind of on its way to working is care of that particular blog where he said, hey, you'll throw it together in a night. It took me a bit longer than that, but he knows what he's doing and I don't. Well, believe it or not, that is a ZL3, so that's a New Zealand station. So I am assuming that this is most likely reception on 7 megahertz rather than 3.5 for that distance. But I may be wrong about that. Fortunately, I don't have another receiver that I can check. So at any rate, it tells me that the antenna's working not too badly, and the receiver's picking up stuff from New Zealand. This is the sweet sound of continuous wave Morse code. And what you see before you is probably what should have taken a day, but it's probably taken closer to a week to achieve. Is this a working receiver? Probably not. But have I learnt a lot in the process of creating this jumble that you see before you? Most definitely yes. Now, the signals we're hearing here may be on the 7 megahertz band, they may be harmonics, they may very well be 3.5 megahertz. It's very hard to tell because at the moment we have no tuning on the front end of this receiver. This is very bare bones. We have a variable frequency oscillator using a ceramic resonator here. I seem to be very good at building those. This has been very easy for me to achieve. So I'm thinking that for building CW transmitters, once I get my license, I shouldn't have too much trouble, fingers crossed. But I learned how to build this double balanced mixer here, the diode mixer. And we have a preamplifier here on this breadboard here. And this giant jumble that you see here is actually a Pixie, or part of a Swedish version of the Pixie. But it didn't really work, but the amplifier on it does work, and that's what you're listening to now. It's not as loud as I'd like it to be. I'm hoping once we build our RF amplifier stage, things will improve somewhat. But honestly, as crappy as all this is, the feeling of actually getting this to do something and receive a signal is pure and utter elation.